Ever wondered how long our beloved Earth will exist? First off, while Earth itself will stick around for billions of years, life as we know it? That's a different story. The planet's surface and atmosphere will undergo dramatic changes. Let's dive into the fascinating future of our planet and explore what lies ahead for Earth. Scientists predict that in roughly 1.3 billion years, our planet will become uninhabitable for most life forms. This is due to a combination of factors, including the sun's increasing luminosity. Why? The culprit here is our very own sun. As it ages, it will undergo significant changes that will impact Earth. The sun, our life-giving star, is on a slow but steady journey through its life cycle. It's currently in its main sequence phase, burning hydrogen into helium. As it ages, it will run out of hydrogen, the fuel for its nuclear fusion. This process is what keeps the sun shining and providing energy to our planet. This will cause the sun's core to compress and get hotter, leading to the expansion of its outer layers. The sun will become a red giant, a phase that will dramatically alter the solar system. In about 4.5 billion years, the sun will transform into a red giant, growing so large that it will engulf Earth. This will mark the end of our planet as we know it. According to Milankovich's theory, the planet will continue to undergo glacial periods at least until the Quaternary glaciation comes to an end. These glacial cycles result from variations in the Earth's orbit, axial tilt, and precession. Plate tectonics will also play a significant role in Earth's future. As part of the ongoing supercontinent cycle, it's likely that a new supercontinent will form in 250–350 million years. Sometime in the next 1.5 to 4.5 billion years, Earth's axial tilt may begin to undergo chaotic variations, with changes of up to 90 degrees. In about 600 million years, carbon dioxide levels will fall below the threshold needed for C3 carbon fixation photosynthesis, used by most plants. In about 1 billion years, the sun's luminosity will be 10% higher, transforming Earth's atmosphere into a moist greenhouse and causing runaway evaporation of the oceans. In 2–3 billion years, Earth's magnetic dynamo may cease, leading to the decay of the magnetosphere and an accelerated loss of atmospheric volatiles. 4 billion years from now, Earth's surface temperature will rise dramatically, triggering a runaway greenhouse effect and creating conditions even more extreme than present-day Venus. By this point, all life on Earth will be extinct. Finally, the most probable fate of our planet is absorption by the sun in about 7.5 billion years, when the star enters its red giant phase and expands beyond Earth's current orbit. The sun, a seemingly eternal beacon of light and warmth, is not immune to the inexorable passage of time. The sun's energy generation is based on the fusion of hydrogen into helium within its core. This process, known as the proton-proton chain reaction, has been sustaining our star for approximately 4.6 billion years. But as hydrogen is consumed, helium accumulates in the core, unable to fuse at the relatively low temperatures currently present. Presently, nearly half of the sun's core hydrogen has been exhausted. As hydrogen atoms dwindle, the core contracts, increasing in temperature and density. This contraction allows the remaining hydrogen to fuse at a faster rate, leading to a gradual increase in the sun's luminosity. When the sun first ignited, it radiated only 70% of its current luminosity. Today, it shines brightly, having increased its energy output by 1% every 110 million years. In a mere 3 billion years, the sun will be 33% more luminous, and in 5 billion years, it will have exhausted its core hydrogen, reaching a dazzling 67% increase in brightness. At this juncture, the sun will enter a new phase, burning hydrogen in a shell around the core and increasing its luminosity by 121% above current levels. This marks the end of the sun's main sequence, heralding its transformation into a subgiant and eventually a red giant. As the sun swells into a red giant, its outer layers will expand, potentially engulfing the inner planets, including Earth. The once life-sustaining sun will become a harbinger of destruction, its intense heat rendering our planet uninhabitable. The collision of the Milky Way and Andromeda galaxies, expected to occur around this time, could further complicate the fate of our solar system. As we look beyond the fiery future of our sun, we must confront the ultimate fate of Earth. After the sun exhausts its core hydrogen and transforms into a red giant, it will eventually shed its outer layers, creating a stunning planetary nebula. At its core, The Sun will collapse into a white dwarf, a dense remnant composed primarily of carbon and oxygen, with a mass about 54% of its current value. But what of Earth and its celestial companion, the Moon? Currently, the Moon drifts away from Earth at a rate of 4 centimeters per year. If our planet and its satellite are not consumed by the Sun, they will eventually become tide-locked in a stable orbit, each showing only one face to the other. In this distant future, the tidal forces of the Sun will continue to extract angular momentum from the Earth-Moon system, causing the Moon's orbit to decay and Earth's rotation to accelerate. In roughly 65 billion years, this intricate dance may lead to a dramatic conclusion: the Moon colliding with Earth. The remaining energy of the Earth-Moon system, sapped by the remnants of the Sun, will drive the Moon slowly inwards until it meets its fate. Beyond this cataclysmic event, the ultimate destiny of Earth hinges on the cosmic forces that govern our galaxy. Over a span of 1 quadrillion years, the planets in our solar system will likely be ejected by close encounters with other stellar remnants. Earth, if it survives these encounters, will continue to orbit the galaxy for around 10 quintillion years before potentially falling into a supermassive black hole or being ejected into intergalactic space. In the unimaginable expanse of time, if Earth is ejected, it will eventually evaporate into radiation over a period of 100 undecillion years. As we contemplate the distant future of Earth, it is essential to consider the ultimate fate of the universe itself. First, let's explore the Big Freeze, also known as heat death. In this scenario, the universe continues to expand indefinitely. Over trillions of years, galaxies drift further apart, stars exhaust their nuclear fuel, and black holes evaporate through Hawking radiation. Eventually, the universe reaches a state of maximum entropy, where no thermodynamic free energy remains to sustain motion or life. All matter and energy would evenly disperse, leaving a cold, dark, and lifeless cosmos. Next, we have the Big Rip, a more dramatic and cataclysmic possibility. If the universe's expansion accelerates without bound due to dark energy, it could reach a point where the fabric of space-time itself is torn apart. Galaxies, stars, planets, and even atomic particles would be ripped to shreds. This violent disintegration would culminate in the ultimate destruction of all matter. Lastly, we consider the Big Crunch, a scenario where the expansion of the universe eventually halts and reverses. Gravity would pull galaxies back together, leading to a contraction of the universe. As everything collapses into a single point, the density and temperature would rise to extreme levels, potentially resulting in a new Big Bang, a cyclical model of cosmic rebirth. In conclusion, the future of Earth is shaped by a myriad of factors, from cosmic events to human influence. While the exact timeline remains uncertain, it is clear that our actions today will impact on the planet's destiny. Let us strive to make choices that ensure a sustainable and thriving future for generations to come.